We're back again, and we are going to dive into gut stuff. Now, I know we get lots and lots of questions about gut issues and how people really struggle. They have been told all the things they need to do a gut cleanse in order to feel better, not be bloated, all that fun stuff. But why don't you talk to us about the gut, how it detoxifies, and anything just brief.
Okay, so basically, gut, it's very complicated, so making it simple. If you want to just separate, we have two types of bacteria, okay? A friendly bacteria and non-friendly bacteria, okay? There are aerobic and anaerobic, okay? Aerobic, which means they thrive on oxygen, these are the one we need them, and anaerobic, with oxygen, nitrogen, it's basically bad. Now, the very important thing is why people develop a lot of gut problems and also infections and all kinds of viruses. Every virus, every pathogen which means something which is not friendly to our body healthy system, okay, metabolism, needs environment to thrive on, okay? And the most environment rich for viruses or any bacteria which are unfriendly in the gut too, it's iron. Iron is very important for us, but it's extremely crucial and important for bacteria. They thrive on it, and they also need glucose. So when you mix glucose, which is high levels when people are insulin resistant, on your iron overload, you have a very high iron buildup in the gut flora. Okay, that's right there gives them a very high level of multiplying and controlling against friendly bacteria, which we need for digestion. Okay, very important parts. We have a hormone called hepcidin. Without going in other hormones which are involved, hepcidin is a master hormone to extract digestive form, okay? And remember, metabolic form of iron versus digestive is different. The digestive, it's a lot more primitive, okay? So hepcidin has to basically to convert that iron, which is digestive form.
I think you hit mute. Yeah, you muted there. I don't know what happened.
How about now?
We're back.
Okay, sorry.
It's okay. Get back into it.
I have to stop touching things.
Yeah.
So going back, so we need absorption of iron, and hepcidin, it's getting this iron, which is iron in the digestive form. And hepcidin extracted iron and delivers to liver. When liver start to distribute that iron, that needs the glycoprotein iron binding in order to transport that particular iron to the bone marrow. At the same time, it stores in liver in ferritin cells. So when hepcidin is disrupted, and very important is hepcidin is a hormone. Hormones are also made from amino acids, the one with mother's passes to our body, which is in glucoferrin. So without that structure of hormone sulfur bonded, we're losing the structure of the hepcidin hormone, so become dysfunctional, just like insulin or bile formation. So we're losing absorption of the iron for our benefits from digestive system, and we start to leave it too much unabsorbed form of digestive iron in the stomach to start to provide a perfect environment for pathogens to breed and multiply, which is the unfriendly gut flora. Okay, so by regulating hepcidin is the main regulator of iron in digestive system, not how much probiotics you're going to take or whatever you're going to add it, is the hormone hepcidin which regulates. Then we go into the endocrine system again, and necessity of iron binding proteins, amino acids, to create and secrete this hormone, okay, to be properly extracting iron. At the same time, glutathione which is also produced by liver, the master antioxidant, is in the digestive system to help actually to sort it out the better amount of iron for our body utilization and help as a chelator, which is chelating, it's removing, to remove excessive iron from being stored and laid down in digestive system, okay? And I just give you, for instance, like Crohn's disease or diverticulitis. It's basically, everybody knows who is in that business, this is actually caused by iron overload hemochromatosis. It's not taboo.
But
Okay.
why don't they tell people that? Like, I don't.
Well, if you go to internet, just put diverticulitis and put Crohn's disease, and it tells you it's hemochromatosis. It's right there. You can Google.
Okay.
Okay. So the buildup of the iron creates instability. So you have to remember, when you take probiotics, you basically try to increase the numbers of the good bacteria. It doesn't matter. They go there and they get slaughtered because our bacteria, the one we needed, they don't get feeding properly done because there is, again, a lack of the iron binding protein in digestive system, which is lactoferrin from mother's milk and glucoferrin in our formula that actually feeds the good bacteria and basically steals the other bacteria from being fed. It's like a divine concept of starving the bacteria from iron and glucose and feeding our own, and glutathione, it comes and removes iron and glycogen excessively stored in the stomach to stop feeding the process. So you go into the core of the process of regulating, not just by putting something in your stomach to try to hoping that she's going to start to work. Again, you are treating a singular event. You're not treating an origin of the problem, which is iron overload in digestive system, dysfunction of glutathione, and dysfunction of hepcidin hormone. So that's how basically digestive flora works. So by adding anything to your stomach, you're not making any difference. Secondarily, when people have a lot of iron, they develop a lot of stomach discomfort because if you take iron itself, it causes you stomach bloatiness. Okay, when you even sloughing off iron from your digestive system, you may have on the beginning some bloatiness because you start to have higher iron level sloughing off from your lining of your digestive system and being reabsorbed. So this is actually the bloatiness, discomfort is not just bacteria by itself, is the iron overload itself in digestive system will cause this reaction in the people. So regulating the iron absorption through iron binding protein and regulating liver releasing hepcidin, that's how you regulate gut flora. Also, the lactoferrin in mother's milk, when the mother feeds the baby originally, it provides certain types of friendly bacteria coming with lactoferrin to the gut digestive system of the baby to start to actually trigger the good non-pathogenic bacteria to grow in order to control the pathogenic bacteria. Now, also at the same time, when your hemoglobin is working, you provide higher oxygen level. Remember, oxidation in the bad bacteria, there are non-aerobic, which means oxygen will actually, with nitrogen, will basically execute them. It will kill them. And the non-pathogenic bacteria, when they get oxygen and nitrogen, it actually feeds them with the iron, hemoglobin, and glucose to make them stronger, to actually create a very good environment and balanced gut flora.
And Christa, to answer your question, why don't they just tell you that? I just feel like a lot of when are the last time some of these doctors, your doctor has picked up a research article or a book, so they may not just be as informed, and there isn't a medication for that, right? So they're going to treat it with anti-inflammatory agents or,
Yeah, that makes sense.
What just Kristy said, they're treating a singular event. You see, they're treating a symptom.
Right.
Every time you're going to treat symptom, you're going to fail. You have to regulate liver, you have to regulate hepcidin, okay? and you have to regulate everything else in order to feed them. Now, for instance, if people have a very bad digestive problem and infection, there is a test actually. They test people for amount of lactoferrin in the digestive system, because lactoferrin start to accumulate actually naturally from our body to help to kill the bad bacteria. So there is actually test for lactoferrin in digestive system when people have a gut flora problem.
So, okay, so what about like the parasites, the bugs, H. pylori, fungus,
Okay.
mold?
Yeah. Okay. So you have to remember, fungus, H. pylori, like any pathogen, any bacteria, they will thrive in the iron-rich environment. Whether it's a digestive system, whether it's your lung, whether it's your sinuses, or anywhere in the body, bacteria needs, and virus and parasite and fungus, they need iron and glucose to thrive and multiply. And also, how they also work, they need glucose. Most of the pathogens have around 30 plus insulin receptors. Human body cells, they have only 4 to 6 insulin receptors. So in a rich environment of iron and glucose, the pathogen will always outcompete us for glucose absorption, so they can multiply and outdo the good bacteria and promote their own growth, like funguses and parasites. If you reduce iron environment and glucose by utilizing for our body, you basically weaken them. You make them very, very difficult for them to defend themselves. At the same time, we're going to go one more time back to the bone marrow. The white cells are the soldiers which kill the bacteria and pathogens, okay? If the red blood cells not working because iron and hemoglobin is not working together to create red blood cells and hemoglobin, your white cells are not working either. You have to correct the red blood cells to make white cells work strong too. So you have a very weak white cells, you have a rich environment in iron and glucose, you create a perfect environment for any type of bacteria, pathogen, fungus, parasite to thrive and be multiplying with the speed of light and taking over our system.
I'm just gonna say like mic drop, but I feel like there's still like I'm trying to think of some other things that people would ask around the whole gut situation. So basically we're saying that these bacteria are feeding off of everything that we're supplying it with. So we've given it iron, we've given it too much of the glucose, and now it's just living and thriving in that environment.
Yes.
And okay, here's my next question then. We have to create, I think a lot of people struggle with either diarrhea or constipation. So obviously we need, in order for us to like remove all of that, we have to have a healthy bowel, right?
Okay.
Have an emptying pathway available for the, the detoxify, in order for the toxins to leave us, right? So can you talk about that?
Yes. Well, you're very important you say this. You see, the bowel movement, I'm going back right now, it's all based on bile production. If your bile is not working, you're not going to have a bowel movement. You see, not enough bile, it's constipation. Too much bile, which is not working properly, is not properly balanced, and amino acids and salts and water, it's going to give us diarrhea. So bile is regulated, not a fiber, not bacteria balance, it's the bile which regulates a bowel movement. And I hope everybody listen to this, because that's how it works. So bile is the ultimate regulator of our digestive bowel movement.
So step away from the Metamucil and
definitely. Fiber is not solution, okay? Right. It's just helper, but it's not addressing the cause. The cause is the bile. If your bile is working, just bile will regulate everything perfectly. And anybody who study endocrine system, they know that bile will actually stimulate every single enzyme which comes from pancreas,
Hmm.
and emulsified it in the duodenum. And that's when people don't have, for instance, proper bile movement and proper secretion of amino acids enzyme from pancreas. That's how develop the celiac disease, because that's happened in duodenum. They don't have a power to break down and absorb all the foods coming from digestive system, stomach, which is called chyme, Hyme. And chyme, it's also very important. It comes in the very acidic form, which is 2 pH, and it's supposed to come. And bile, one of the main function of bile with the enzymes and bicarbonate, we produce our own bicarbonate in pancreas. So between the bile and bicarbonate, we're changing the pH from the chyme from stomach to possibly above 6.4, because if it's below 6.4, we cannot break down in small intestine and large intestine, so we cannot actually absorb it. And that's what you start to lay in our digestive system and not moving, creating even more hostile environment for us, creating too much iron deposits and too much glycogen deposits to create the bad bacteria to thrive. So that's very important, our bile and enzyme, to change the pH from the food coming from stomach. Now, some people say, what would we need to change pH in stomach? We shouldn't. We need to have 2 pH, because this is the only way the acid in our stomach breaks down the food. Then by emulsification from bile, we change into higher pH, and then the colon and small intestine can process and absorb.
Hmm. Well, my friends, I want to hear all the questions about this one. I feel like this was one that we're going to get a lot of questions on. So you know how to reach us. Just, yeah, send them our way. And thanks again for being here.